Here we are asked to find the limit of these four functions as x approaches infinity. We notice that in these functions, the numerators are constant and the denominators are powers of x. So f of x is equal to 2 divided by x to the first power. G of x is 5 divided by x to the first power. H of x is 3 divided by x to the second power, and m of x is equal to the negative 5 divided by x to the third power. So if we want to find the limit of these functions as x approaches infinity, we are going to make the denominator extremely large. And what happens when we divide a constant by an extremely large number? The answer is very, very close to zero. So keeping that in mind, we know now that the limit of f of x as x approaches infinity is almost equal to zero. Or that's the limit. The limit is equal to zero. It does not mean that f of x is equal to zero. It just means that f of x is getting closer and closer to zero. For g of x, it will be the same thing. So we'll have the limit of g of x as x approaches infinity is equal to 0. Limit of h of x as x approaches infinity is equal to 0, because when you make x very, very large and you square that very, very large number, and you divide 3 by that very, very large number, the answer is very, very close to 0. Therefore, the limit of h of x as x approaches infinity is equal to 0. And the same thing will happen to m of x. If we make x very, very large, cube that very, very large number, then we are going to get an even larger number. Then when we divide negative 5 by that very, very large number, the answer will be closer to 0. So we say that the limit of m of x as x approaches positive infinity is equal to 0.